Welcome. We're going to take a look at 1.6 page 4 now. This is a pretty quick page, but does show some understanding on it. Does the function have an inverse? When we're asked, does the function have an inverse? A function has an inverse if and only if. That's a tight marriage right there. F is 1 to 1. They might as well be asking, is it 1 to 1? So 36, we know it's a function, they tell us so. Coincidentally, the elf in charge of 1/2 hour and 1 hour are both told to turn that into 40. 2 hours 70, 4 hours 120. However, if my L's were charged with this, hey, we're going to tell you what the dollar amount is, you tell me how many hours it took. Oh, $70, 2 hours. $120, 4 hours. $40, I don't know. This does not have an inverse because it is not 1 to 1. Okay, here we have 2's becoming 4's, 3's get turned into 7's, 7's get turned into 2's. It's most definitely a function, although they tell us it's a function, but it's also 1 to 1. If you're the elf outside the tree that received a 4, you knew it went in as a 2. If you get a 7, you know it came in as a 3. If you get a 2, you know it must have come in as a 7. So it has an inverse because it is 1 to 1. Okay, pretty simple concept, and in some regards, when we have the graph, as I often say, the answers are in the graphs. Generally speaking, it's easier. So determine whether the graph is that of a function. Well, if it's a function, does it pass the vertical line test, number 40? Oh, 40 definitely passes the vertical line test. It is a function. If so, is it 1 to 1? Horizontal line test passes through 2 points at some spot. Therefore, it's not 1 to 1. It does not pass the horizontal line test. It is a function, but it is not 1 to 1. So make sure to answer both those questions. 42, is it a function? Vertical line test, it is a function. Does it pass the horizontal line test? Yes. It has an inverse. 44. Function? No. It is not a function. Take a look at the directions now. Determine whether the graph is that of a function. If so, then determine is it 1 to 1. We don't even need to determine whether this is 1 to 1. Okay, so it is not. We're just done at that point. Okay, and here we're going to actually use our graphing calculator on this. Here's some functions that we might know what they look like. I'd hope maybe we have a pretty good idea what this one looks like, but probably not so much this one or this one. So let's go ahead and do this. So use a graphing calculator to graph the function and use the horizontal line test to determine whether the function is 1 to 1. So a little bit like what we're doing in 39 through 44, other than we already know it's a function and we have to create the graph. So negative 2x second square root 16 minus x squared, and I think I'm in Zoom standard, but I'll just double check. Zoom 6. We got some stuff going on here, and interestingly, this looks like it just dies at 4, and we can kind of see, oh yeah, I expect it to die at 4, but I think maybe we want to look up and down a little bit further on the graph. Although, you know what? We know it's a function already because we were able to enter it. It's already solved for y, and I have enough information right there to know it's not 1 to 1 because a vertical line would pass right through 2 points in a number of places. And I actually suspect this 4 goes all the way there to 0. Let's see, second calc value 4, it actually does. So our calculators will lie to us a little bit. If I go to 4.0001, it does not exist there. So anyway, our graph looks like that. And if you don't have it all the way to the zeros because your graphing calculator didn't show, that's fine. But so you do need to sketch the graph again, so I don't assume you're just writing down answers. Use the horizontal line test to determine whether it has an inverse. No inverse. Okay. Y equals clear x to the 5th minus 7. Graph that. It's going to get big in a hurry. And it is a function. Here's the tough one, though, is what's going on here? It looks like maybe a horizontal line test hits a whole lot of points. And that's down 7. I'm going to actually zoom in on this. I'm going to go window. I'm going to go -1 to 1. Nope, you know what? I'm going to not do that. I'm just going to keep this at -10. I'll show you another option just because I want to feature this. I'm going to go zoom box. Here we build a little TV screen around the part that we're interested in. So I'm going to move out here to the left. I notice I'm still above -7 right here. So I'm going to hit enter. I'm going to go down below -7. I'm going to come across here. And as soon as I hit enter here, it's going to blow that up. And I start to believe maybe that's still increasing there, but watch this. Zoom box again. Notice I'm still above -7. I'm going to really try to stretch this thing out vertically. Hit it. I hit enter, building my box below 7. Enter. And see how it continues to kind of look flat? If we continue to do that, it's going to end up appearing like and becoming clear. We could even do this, trace. Let's watch this. As I come along here, see how it's kind of going? The values are getting less negative, so they're getting bigger and bigger. Now, that's just rounding error there. There would be some reason for us to make an argument. You know what? I think it doesn't pass the horizontal line test. But it does, and that one's kind of sneaky, but yes, it has an inverse. And 56, remember how to graph absolute values? Y equals clear. I like alpha window absolute. In fact, clear before I do that, I'm going to go negative. I'm going to go alpha y equals, take advantage of fraction. Alpha window, take advantage of absolute value. X squared minus 9 on x squared, whoops, delete. Oh, shucks, I'm just going to put divided by now. I lost it. Divided by alpha window, absolute value, x squared plus 7. And let's step out of that, double check, make sure we got what we need there. Wish I would have put it in as a fraction, but now I'm going to go zoom 6 because I have my other graph kind of messed up. Oh, clearly not 1-to-1. Did I ever put the graph of this one in there? I don't think I did. 1, 2, 3, 4, 5, 6, 7. It looked like that. All right, the graph of this one's pretty crazy looking. So it looks like we've got some interesting things at 3 and -3, and 3 and -3 kind of makes some sense to me. But it looks like we kind of go down like this. We come in down to somewhere in here, up there. So we look like that, but most definitely does not pass horizontal line test. No inverse. So again, a reminder, you got some strange graphs here. Go ahead and just jot down the picture of them just so it's clear that you went through this, went through the graphing process. Okay, and we will continue on shortly.